Hello, I'm the awesome tutor. Today we're going to be looking at electrical energy. But first, electrical appliances. Now, electrical appliances, what do? They transfer. The key word is transfer. Electrical energy into useful energy. Why do we say transfer? Because energy, the law of conservation of energy. Energy cannot be created and energy cannot be destroyed. It can merely be transferred. And obviously, not all of the energy is transferred into useful energy. Nearly always, an electrical appliance is never 100% efficient. And the main wasted energy that's nearly always given off is usually heat. And this spreads out into the surroundings. And once it has been spread out, it's less useful, so we can't really use it, so therefore it's wasted. So, let's look at some examples. A light bulb. What would be the useful energy of a light bulb? Obviously, light energy of the glowing filament. What about wasted energy? Heat. A light bulb gets hot, and this means it's not energy efficient because the useful energy is light. Wasted energy is heat. We don't want the light bulb to get hot, we want it to give off light, and so heat is wasted. What about a television? A television, useful energy, obviously, light to show on the screen, and sound, so you can hear what's happening. Wasted energy, again, heat. Kettle. What's the useful energy for an electric kettle? It's heat. But heat what? Heat the water. And wasted energy is heating the kettle itself. We do not want the kettle to be heated up, we want the water to be heated up. So the energy that's used to heat the kettle itself is wasted. What about an electric motor? The useful energy will be kinetic energy, okay, spinning the motor. And maybe gravitational potential energy for the objects at the top, then going down, but kinetic energy is the main one. Wasted energy for a motor, sound, and heat. We don't want a motor to give off sound, we don't want it to get hot, we just want it to move, so these are wasted. A hair dryer, the kinetic energy of the air that flows out, and obviously the heat for drying the hair. But again, what's wasted? The heat, the heating of the element itself, the heating of the hair dryer itself. We don't want the hair dryer to get hot, we want the hair to get hot. We want the heat energy to dry the hair, not to heat the hair dryer itself, and therefore this heat energy is wasted. Next, so electrical power. Power measured in watts or sometimes kilowatts, but we will go on to that later. So power is the rate of energy transfer. 1 watt is 1 joule of energy transferred in 1 second. And from this we get the equation, power is energy over time. If you suck at rearranging equations and you're bad at maths, this handy triangle can help you. Power times time gives you energy. Energy is power times, I just said that. Power is energy over time, time is energy over power. And now we're going to move on to some calculation questions. Okay, a PlayStation 3 can transfer 500 joules of energy in 3 seconds. What is its power? Okay, what is the equation we use? Power is energy over time. In your exam, they will give you this equation. And you should know that in the mark scheme, they usually give you a mark for substituting in the values. So if you just write power is 500 joules over 3 seconds, you get 1 mark, even if the answer is not correct. This is a calculator exam, so you can use your calculator. 500 joules over 3 seconds gives you 166.6 blah, 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 blah. In your exam, they will tell you to either to what decimal place or to what significant figures you should round it to, but I'm going to round it to a whole number, so 167 watts. Remember your units. You could lose a mark if you don't put in the units. Next question. Okay. A weightlifter can lift a 25 kilogram weight by 1 meter in 1.5 seconds. What is his power? Give your answer to 3 significant figures. Now this is a much harder question because you need two equations to solve this. Your first equation, okay, now first of all, if someone lifts something up, what type of energy transfers are going on? Chemical energy from the body transferred into what? To lift something. Once you lift something, what energy does it have? It has gravitational potential energy. And so use the equation, gravitational potential energy gives you mass times gravitational field strength times the height. And gravitational potential energy is energy, is it not? Yes, it is. And so power is energy over time. The energy is gravitational potential energy. So once you figure that out, you put it here. And you have your time. So now you have everything you need to do to figure out the power. Let's substitute in some values. Okay, energy. What's the mass? 25 kilograms. The gravitational field strength of Earth is about 10 times by the height, which is 1 meter. That is going to give you 250 joules. Remember, this is a calculator exam, so you can use a calculator. So that's your energy. Now power is energy over time. So we have our energy, 250 joules, divided by the time, 1.5 seconds. And that is going to give you 1.5. Oh, that's convenient. It's the same answer as before. But it wants it in 3 significant figures. So, 1, 2, 3, 167 watts. Remember the units? But in your exam, they might give you a unit, but sometimes they won't. So, watch out for that. And now let's move on. Okay, efficiency. When we talk about efficiency, we talk about how much energy is transferred usefully compared to how much energy is put in. So basically, what that means is efficiency is the useful energy output over the total energy input. But in this case, we're talking about power. So the same thing applies. Useful power output is the same over useful power, total power input. So the useful power out divided by the total power that you put in. And this will give you a decimal. And in the exam, you should write the efficiency as a percentage unless they tell you otherwise. So we times it by 100 to convert it from a decimal to a percentage. Now let's try some questions. Okay, the power output of an electric motor is 30 watts if we put in 100 watts of power. Calculate the energy efficiency of the motor. So, efficiency is useful power out over total power in. Useful power out, over total power put in. So, substitute in the values. The power output is 30 watts. The power input is 100 watts, and this will give you 0.3. Let's convert it to a percentage. So times by 100 gives you 30%. Next, a light bulb is 15% efficient. It transfers 100 joules in 1 second. How much power is wasted? Now this question may look tricky and hard, but it's pretty easy. So what are the equations we need? Power is energy over time, and energy is efficiency is useful power or energy out over total power in. First of all, we have energy in joules and time in 1 second. What is the power input, the total power input? 100 joules divided by 1 second gives you 1 watt of total power input. And we know that the light bulb is 15% efficient. So 15% of that 1 watt will be useful power. But 85% of it will be wasted power. So How do we calculate the power that's wasted? Well, if 15% of 100 watts, made a mistake there, 15% of 100 watts is 15 watts. So 15 watts of power is useful. And what you could do now is 100 watts minus 15 watts to give you the power that's wasted. Or if you work out the percentage that is inefficient, so 85%, and then you 85% of 100 watts, that will give you 85 watts. Or you could do it like this. 15% of 100 watts is 15 watts, so 15 watts is useful. So 100 minus 15 gives you the thing that's wasted, and that's still 85 watts. So either way, you get 85 watts. Yeah, again, it looked difficult, but it's actually pretty easy once you get your head around it. Next, okay, the kilowatt hour. Before we had energy is power times time, when energy is in joules, and power is in watts, and time is in seconds. Now we have energy in kilowatt hours is power in kilowatts multiplied by time in hours. Kilowatt hours, kilowatts times hours. Self-explanatory. But why do we use the kilowatt hour unit instead of just normal joules? Well, because the numbers get too big. Here's an example. A school computer server outputs 100,000 watts of power in 3,600 seconds. How much energy is transferred? Well, energy is power times time. So, power is 100,000 watts multiplied by 3,600 seconds gives you 360 million joules. That's what I mean. The numbers are too big. So instead we use kilowatt hours. Okay, energy is in kilowatt hours, power is in kilowatts. How do we get from watts to kilowatts? A kilowatt is just 1,000 watts. So we divide by 1,000. So 100,000 watts is 100 kilowatts. And 3,600 seconds is 1 hour. Oh, look at that. The numbers are smaller already. 1 hour times 100 kilowatts gives you 100 kilowatt hours. Isn't this a much nicer number than this? Of course. And that's why we use kilowatt hours. Next, paying for electrical energy. An electricity meter is usually used to measure how much electrical energy you use, and it measures it in kilowatt hours. So here we have a reading at the start of the month. Remember, this is in kilowatt hours, and a reading at the end of the month. And each kilowatt hour costs 10 pence. What is the total cost of energy used in this 1 month? Well, total cost is number of kilowatt hours multiplied by the cost per kilowatt hour. We know the cost per kilowatt hour, it's 10 pence. What we have to figure out is the number of kilowatt hours used for 1 month. Here we have the start of the month and the end of the month. So what we do is a simple subtraction. Put that into your calculator because I hate mental maths. All the way around. 11,326 minus 7,581 gives you 3,745 kilowatt hours used during this month. And so, to work out the total cost, it's 3,745 kilowatts multiplied by 10 pence gives you 37,450 pence. Make it in pounds better for you. So 374 pounds 50. Remember, look at the unit. In your exam, they might give a unit of a pound and you might not see it and write it down in pence. So always watch out for this. Next, cost effectiveness and payback time. Now in your physics exam, they love to ask you questions about this. I've seen a 6 marker on it. And they usually give you electrical appliances and some information on them, and they ask you to compare the cost effectiveness or sometimes the payback time. Let's look at this. A filament bulb has a power of 100 watts. Its efficiency is 20%, lifetime 1,000 hours, and cost per bulb is 50 pence. An LED, 25 watts, 80% efficient, 15,000 hours of lifetime, and £2.50. So if this was a 6 marker, how would you answer this? Well, a filament bulb is more powerful than an LED. So filament, more powerful. However, an LED is more efficient. And because the LED is more efficient, less energy is wasted. And that is really important when we talk about payback time. But we'll talk about that later. So less energy wasted. And lifetime and the cost per bulb. Here, if you make a calculation, the examiner will love it. So, 15,000 hours for one LED. How many filament bulbs will you need to get a lifetime of 15,000 hours? Well, 15,000 divided by 1,000. There's some maths involved, so if you don't like maths, just say one has a longer lifetime, and so that's better, lasts longer. But if you are good at maths, then it's useful to make a calculation. So from the calculations I can make, you would need 15 filament bulbs in order to get the same lifetime as one LED. And so which one is more cost effective in the long term? If one LED costs you £2.50, and you need 15 filament bulbs to get the same lifetime, 15 multiplied by 50 pence gives you £7.50. So which one is more expensive in the long term? That's the filament bulb. Although it is very cheap for one, it's more expensive in the long term for cost effectiveness. And that should get you 6 marks if they give you 6 marks on this. Now we're going to talk about payback time. Okay, so I was going to talk about payback time, but payback time is more suited for the heating in the home topic with like loft insulation and stuff like that. And it's not really suited for the electrical appliances topic at this level. So yeah, I'm going to stop right there. This has been the Awesome Tutor. Bye.